So continuing with lesson number 9, data and statistics. I'm on page 64 there, and we've got exercise number 1. So we've got Terrell. He works at a car factory. He's reading a company report that shows the number of cars produced during the 6 months of the year. All right, so notice how we have the months down here, and this is a bar graph. It's also called a histogram, if you care, but we call it a bar graph in math. And so we've got the months, the time periods down here, and the numbers up here on the left. And this is generally speaking the way it is. So each month are produced different number of cars. So in January, 150. We go to April, we're looking at, looks like 225, halfway between 200 and 250, etc. All right, so we're going to use that and go to the next page and answer some questions here. So during which month was the minimum number of cars produced? So it makes it real easy. You just look at the graph and find out where the shortest graph is, and here it's January. And during which month was the maximum? So remember, minimum is the smallest, maximum is the greatest. What is the average number of cars produced during the first 6 months? So if you remember from the lecture, in order to find the average, you add up all of the numbers here. So 150, 175, 225, 225, 300, and 275, because that's between 250 and 300. So you add all those numbers together, and then you divide by the total number of numbers. So 1, 2, 3, 4, 5, 6. So you're going to add all these up and then divide by 6, and that'll give you one of these numbers here. And number 4, Terrell is asked to make a prediction about the number of cars that the factory will produce in July, which means this goes to June. So we're trying to guess how many cars are going to be made in July. So your choices are none, 225, 300, or it's impossible to estimate. All right, so you're just going to have to come up with what you think would be possible. Do you think it's going to get higher or lower based on previous data? So here, it started to go up, and then it stayed the same, and then it went up, and then it went down. So do you have any idea what July will look like based on this here? And that's what they're asking for that particular problem. So if we continue on, I'm going to get rid of this one here because we're done with that. If I can make it go away here. And we're going to go to the next exercise 2, charitable contribution. So Marisol, she works at a local charity. She created a circle graph. Notice she's got a circle graph, so it's real easy to compare the different things in here. So she's got a circle graph to help her to see money donated to charity. Now you have to have a little, it's called a legend, L-E-G-E-N-D, to tell you what the different colors represent. So this color, which is this one here, represents individual, and the dark gray represents government, program, other revenue right here, and then investment income right here. So each one of these colors represents something here. So what is the largest source of contributions for the charity? Well, you're just going to look and see which color is the biggest there for that. All right, so it's gonna see if I can find the rest of these pages. Okay, so number 2 at the top of page 66 is continuing to ask questions about the circle graph here. What percent of contributions came from sources other than individual? All right, so we got all of these individual ones, and we need to know this over here. Okay, what percent came from other than individual? So what you do there is you find out how much money was donated total. So we found out when I added all those up, you had $53,000. That's the total. I'm trying to find what part of that $53,000 this is. So I'm going to add this and this and this and this together, and I get 13,250. So 13,250 of the 53,000 total was coming from sources other than individual. So if I take this part of this whole and I divide that, I'm going to get a number like, I think it's 0.25. So if I get 0.25 there, 0.25, then I have to change that to a percent. And if you remember, in order to change something to percent, all you do is move the decimal 2 places to the right, and it becomes a percent. So then you have to look and see which answer is going to be the correct answer. All right, so if you continue down, let me erase this stuff here. Marisol, in number 3, reviewed her records. Notice that the charity received 1,232 individual donations. Which of the following shows the average amount of an individual donation? All right, so if you remember, in order to find the average of something, you add all of the parts, which we don't there's only one part. That part is 39,750. That is the whole part. That is individual donations. Then you divide it by the number of people that donated. And that would give you the average number of dollars that were donated there. So that's number 3. All right, so let's look at exercise 3. Let's get rid of some of this stuff and just go right here to exercise 3. Move this out of the way here. So Taylor works on a small farm. She collected the amount of rainfall from 6 different weather stations in her area. Weather stations A, B, C, D, E, and F. That's a real unique name for weather stations. I'd give them names like Frank and Lucky and that kind of thing, but she displayed the data in the table below. So each one of these weather stations had a certain amount of rain that happened. So 5.3 all the way up to 10.3 down to 3.3. So different inches of rain. So Taylor wanted to display the data as a graph. What kind of data should she, or what kind of graph should she use? So you have a choice of a bar graph like this, or a circle graph with different parts there. So which would have been the better way to display the data, in a circle graph or a bar graph? I would choose the bar graph personally, simply because it gives me a number amount, and it also gives me the weather stations. So what I would do is I would do the weather stations A, B, C, D, etc. And I'd go, okay, A was 5.3, B is 7.5, notice it's bigger, C is 10.3, D is 3.3. So it's a lot easier to find out which weather station had the most rain and which weather station had the least amount, rather than a circle graph, which is a little trickier. I mean, circle graphs are good for certain things, but not when you're comparing not when you're comparing things. Circle graphs are better when you're looking at how big of a part is there of the whole, rather than comparing individual things like we're doing here. So the weather station had the maximum. Which weather station had the maximum amount of rainfall? Well, you can look at this graph right here and tell pretty quickly what that is, and I'll let you do the rest of those problems on your own. Okay, so top of page 67, we've got some questions. Now we're looking at this group of numbers. Let me get my handy dandy little highlighter here. We're looking at this group of numbers right there. All right, it's a little tricky the way they have it written. So what is the minimum value of the data set? This is the data set. 15, 7, 8, 12, 4, 20, 6, and 7. All those numbers make up the data set. There's 8 numbers there. What is the minimum value? So you'd look at this, say, oh, 4 is the smallest number. What's the maximum? What's the average? Remember, to find the average, you add up all those numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8 numbers. How many numbers in the data are below average? Well, let's just say I'm going to just make up an answer here for number 3, so it's not actually the right answer, but let me say I put 13 as the average. How many numbers are below average? Well, 1 number, 2, 3, 4, 5, 6 numbers are below average. How many numbers are above the average? Well, let's see. 15 and 20 look like the only ones. So that's what you do for those two. Find the average and then find which numbers are below the average and which numbers are above. Your reflection, one thing you learned in this lesson. What did you learn? I mean, there's got to be something that you learned from doing this lesson. How will you use what you learned? Well, if you know the average of something, that can be pretty important. If you want to know, like, the average score of, let's say, the Chicago Cubs baseball team over the course of the entire season. So you can figure averages out in sports. You can figure them out in payroll. I mean, just all kinds of stuff. And that is it for lesson number 9.